Let's just go through an example of manually fitting the least squares equation. So consider the data set Swiss. So if I do data Swiss, and then here's the data set. Head Swiss. There's the data set. We want to use fertility as an outcome and predict it using agriculture, examination, education, Catholic, and infant mortality, and an intercept. So let's create an X matrix that is the Swiss data set minus the first row, first column. Okay, let's see, X, 1 to 10. Okay, there we go. So it now has an intercept, agriculture, examination, education, Catholic, and infant mortality. And let's set Y is equal to Swiss fertility. Okay, so what we're saying is that beta hat is going to be solve X times X times transpose of X times Y. Is matrix X false? X equals as dot matrix X. Now let's try it again. Aha, up, and notice one other thing. X transpose X, so I forgot my transpose there. Okay, now let's see beta. Okay, it gives you a coefficient for each of the terms, one for the intercept, one for agriculture, examination, education, Catholic, and infant mortality. Now let's just compare it if we were to do LM y tilde x. Okay, we see the same thing. Notice it tried to fit an intercept, or I'm sorry, it can't fit our intercept term because it's including an intercept. So obviously it can't include r's intercept plus the extra intercept term. So that one, it just sets as an NA if it has a redundant column in the X matrix. So notice that the terms are of course all the same. Okay, so that's what's going on with LM behind the scenes. I would say I think it's a little bit faster if you do solve T of X times X and T of X times Y. If you give it the two arguments like that, giving it the equations to solve, I actually think that's a little bit faster way to do the inversion numerically. So if you happen to have kind of biggish matrices, you actually want to give the function solve the linear equations rather than actually going through the matrix manipulations. But of course it gives you the same thing. Okay, so that's under the hood what LM is accomplishing when it fits a multivariable regression.